So hello everybody. Today we've got a bit of a physics problem, but it still has a lot of math, so I thought why not, why wouldn't we do this? So a raft is made of 16 pieces of wood. Each of those pieces of wood has a rectangular cross section and dimensions of 3.6 meters, 0.2 meters, and 0.25 meters. If the density of the wood is 840 kilograms per cubic meter, what's the maximum load which the raft can carry without sinking? Okay, so how do we do this? Well, let's go ahead and draw a diagram of our problem first. Okay, so this is 4, and now this is 8. 1, 2, 8. 1, 2, 3, 4. So this is now 8. Okay, so 1, 2. So this is our raft. And let's go ahead and concentrate on the forces which are acting upon it. So I'm going to use colors. So, and we'll say that this is the surface of the fluid. Let's say it's not specified which fluid it is, but I think it's water, so yeah, it's most probably water, so surface of water. And now let's see what forces are acting upon this raft. So the first force that's going to act on the raft like this is actually Archimedes' force. Okay, so this is F Archimedes. Okay, it's the capital A. And now up and now right here we have another force. We actually have two forces. So this is the first one, and this is the second one. So this red force is going to be the weight G of the raft, and this force is going to be weight of the load. I'm just going to call it GL. Now, of course, if we know anything about statics, one of the equilibrium conditions is that the sum of forces must be equal to 0. So, F Archimedes force and minus the weight of the raft minus the weight of the load must be equal to 0. And we're using minus because the weights are acting downwards. So from here, it follows that the weight of the load is equal to Archimedes' force minus the weight of the raft. Now, how do we calculate these two? Well, first of all, Archimedes' force is equal to the density rho of the fluid times G and times the volume of the submerged body. We'll assume that the entire raft is submerged. Now, the density of the fluid, which in this case is water, is 100 kilograms per cubic meter. G is Earth's gravitational acceleration, or 9.81 meters per squared second. And how do we calculate the volume of the raft? Well, the volume of the raft is equal to 16 times the volume of one of its pieces. Why times 16? Because there are 16 pieces. Okay, so the volume of the raft is then going to be equal to 16 times 3.6 times 0.2 and times 0.25. So the volume of the raft is equal to 16 times 3.6 times 0.2 and times 0.25. So the volume of the raft is equal to 2.88 cubic meters. Okay, now once we put these values into the equation for the Archimedes force, we'll get that 1000 kilograms per meter cubed times 9.81 meters per second squared times 2.88 meters cubed, and meter cubed will cancel each other out, so we're left with 1000 times 2.88 times 9.81, and that's going to be equal to 28,252.8. And what's the unit going to be? Well, we see here that we've got kilogram times meter per square second, and that's equivalent to Newton. So the Archimedes force is going to be equal to 28,252.8 newtons. Let's go ahead and find our other force, the weight of the raft. The weight of the raft is equal to the mass of the raft times G, and the mass of the raft is equal to the density of the raft material, which is wood, so rho of wood, times the volume of the raft, and we still have to multiply that by G. So the weight of the raft is going to be equal to 840 kilograms per cubic meter times, we've already calculated the volume of the raft, times 2.88 meters cubed times 9.81 meters per second squared. Okay, so once we calculate all of this, we've got 840 times 2.88 times 9.81, and that is equal to 23,732.352. Again, kilograms times meter per squared second is equivalent to newtons. Now that we know Archimedes force, or the lift force, and the weight of the raft, we can calculate the weight of the load, the maximum weight of the load. So that's going to be equal to 28,000 252.8 newtons minus 23,732.3.2 newtons. So, the maximum weight of the load must be equal to 4,520.448 newtons. And if we want to find the maximum mass of the load, which the raft can carry without sinking, then we'll simply just divide its weight by g, or by 9.81 meters per second. Meters per second squared, sorry. So once we do that, we'll find that the maximum weight is 460.8 kilograms. Okay, so that's going to be the final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.